All right. So guys, I want to go over these notes here just because it's going to help you understand the calculations. It's going to help you understand acceleration due to gravity. I had about 3 or 4 or 5 kids say, I don't really know how to do these calculations for the lab, which is fine. So what you are going to notice, if you haven't noticed already, I'd like to have you do something first, kind of maybe even struggle with it, think about it before I actually then help you with it. That's a really positive way to learn. So I want to talk about free fall today. We are not doing the same thing in here for free fall as we are for action physics. We get into free fall in a more in-depth fashion with action physics. But when you leave here, you will have the same basic knowledge that the kids in the year-long class will have. So, free fall. We know that when you drop an object, or whatever objects, does mass matter as far as acceleration goes? So think about what we talked about, the demonstration that I showed last class when I dropped the sledgehammer. This side is way heavier than this side. When I dropped it, what was the outcome? How did it fall? Flat. So therefore, if we neglect air resistance, mass has no effect on the acceleration due to gravity. All right? Does anyone know what the acceleration due to gravity is on planet Earth? What number we're going to put in for G? 9.8 to be pretty precise. If you want to round it to 10 to make the math easier, that is totally cool with me. So we know that gravity is a major force in our universe. We will talk a lot more about gravity as the year progresses, especially when we get into our astronomy and space unit. But we know that gravity, everything in the universe is attracted to one another. So if we're talking about gravity here on Earth, that's exactly why you are pulled down. You have a gravitational attraction to the person sitting next to you. So why aren't you pulled towards them? Did you just like get sucked into Steve with that gravitational attraction? That was like perfect timing. Why aren't you sliding to the person next to you if you have a gravitational attraction to them? Yeah, exactly. All right. You have a greater gravitational attraction down because the Earth has a much greater mass. So the greater the mass, the greater gravitational attraction, all right, which means technically the greater the weight. So your weight is based on the amount of mass is made up and the amount of gravity acting on you. So weight is nothing more than gravity acting on your mass, okay? You would. Great question. If Earth was bigger, you would weigh more. Exactly. So if you go up to Saturn, you would weigh about 4 times your weight right now. Okay? So when you drop an object, does the speed increase, decrease, or stay the same? It increases. That's why we call it G, the acceleration due to gravity. So therefore, if it's accelerating, it's technically going to increase as it falls. So in fact, we know that here on Earth, give or take a few hundredths, this will change slightly depending on elevation, but 9.8 is the general acceleration due to gravity here on our planet. If we go to the moon is a lot smaller, it has a lot less mass, so therefore the acceleration of gravity on the moon would be smaller. That's why when you see videos of people on the moon, they kind of float a little bit when they walk. So the gravitational attraction is about 1/6 of that. So your weight would be 1/6 on the moon as what it is here on Earth. I put a little diagram up here on the board of a girl dropping a ball, and you're going to notice that every second it increases, the velocity increases by about 10 meters per second. That is the acceleration. All right? So you're seeing that velocity increases. Going to work for me here? So it goes to 10, to 20, to 30, to 40, to 50. So every second it increases its velocity by about 10 meters per second. That's an acceleration, guys. For every second it increases its speed or velocity by 10 meters per second. So we know that is written as meters per second, or meters per second squared, which is the acceleration. So does anybody have any questions on that very basic introduction to gravity and the acceleration of gravity. All right, we got 2 more slides. That's it. Not a lot of notes today. Calculations here. So we talked about 2 formulas that we're going to use for free fall. V equals gt and d equals 1/2 gt squared. So again, you're going to see this over and over. Acceleration due to gravity, acceleration due to gravity. This is what you will always put in any formula that has g in it. Or you may also see these free fall formulas written with an a in it. But a is just acceleration, and you know if the object is falling down, you have to use 9.8 for the acceleration. So if anything is falling straight down and not hitting another object, it's going to be 9.8. So again, you can round it to 10 if that makes the math easier for you. I don't care. It's not that big of a deal to me. So V equals gt. What would we use this formula to find? Free fall stuff. What does V stand for? Velocity. If we know the velocity, we can solve for t, which would be time. Okay? So technically, this could be your velocity at any point within the trip. If we know that it takes, I don't know, 8 seconds for an object to reach the ground, well, if I put 8 in here, this is going to be the final velocity of the object. If we know that it takes 8 seconds to reach the ground, but I wanted to know how fast it was moving 4 seconds into its free fall, well, I could put 4 there, and that'll give me my velocity for 4 seconds into free fall. So depending on what the time is, that's going to be the velocity. Remember, guys, this is saying if air resistance wasn't a factor. All right? Does anyone know what the speed is that a human, if they're jumping out of an airplane, what speed is that we can get to? It's close. I think it's about 120, but it's up there. All right? So that's called a terminal velocity. Every object has a terminal velocity when dropped, which the terminal velocity means this, that it will reach a maximum speed and it will not speed up any further. Why won't an object speed up infinitely as it's falling? Good. So the force acting on it, there's a force acting down, which is gravity. What's the force acting back up on the object? It's falling. Air resistance. Okay? So when the force of gravity equals the force of the air resistance pushing back up, that object cannot speed up any further. All right? So I may give you a word problem saying, you know, a skydiver is jumping out of an airplane. The chute doesn't open, but he's falling for 15 seconds. What's his speed? Well, if you put 15 in here, you put 10 here, and you calculate it to be 150, and you say, well, wait a second. I thought the terminal velocity of a person falling out of an airplane can only be 120. What's going on here? You need to remember that all the stuff we do in here is neglecting air resistance. So technically, if you're in space, free falling. Okay? So V is velocity. G is always the constant. Shouldn't have capitalized because that should be a lowercase g. Uppercase g you're going to learn is a different number. So lowercase g is always 10 meters per second squared. And t is the time that the object is falling. So this formula is pretty darn easy. So it says, what is the velocity of an object that has been falling for 12 seconds? If we're neglecting air resistance, V equals gt. We know that g, I'm going to put 10 in. Yeah. Time is 12. So therefore, its velocity after 12 seconds would be 120 meters per second, neglecting air resistance. Any questions with that formula? So that's right up there on the easy list with speed equals distance divided by time. All right, so this is how fast how fast an object falls. Next slide and last slide is how far an object falls. So obviously how fast it falls and how far it falls are 2 different things. We can figure out how far an object falls based on the time it took to fall. This goes right back to the lab that you guys did last class with the tennis balls. All right? Some of you chose objects super high, and you're throwing the ball up, getting it to the top of the object, and then stopping it when the ball hits the ground. What do you have to do to that time then? If you throw it up and it comes back down, yeah, you got to divide it by what? 2, because all we care about is free fall time. So for people that measure the height of the stairs out there, they just dropped it from top to bottom and timed that. You don't need to divide that by 2. All we care about is free fall time. So d equals 1/2 gt squared. D is the distance the object is falling from. You may or may not know this. I may give you d and try to have you then figure out the time it takes to fall, or I may have you calculate d if you know what t is. 1/2 is a constant. You will always have 1/2 there. When I was coming around, a few people, when I was looking at their calculations for their lab, they totally neglected the 1/2. You have to use the 1/2 in there. You can't just take it out. And g is a constant. Again, that should be lowercase g. I don't know why it should be lowercase g. Uppercase g is another gravity constant that we'll learn when we get into astronomy. So, and t is the time it takes for an object to fall. The biggest mistake that I see from my students is that they forget to square the t. If you don't square the t, if you ignore the exponent, you are not going to do the correct calculation. Okay? So if we look at a very basic problem dealing with this, an apple falls from a tree and hits the ground in 1.5 seconds. How tall was the branch? I want to do this one, then I want to kind of go back and switch some numbers around to show you how to solve it the second way. So, first of all, d equals 1/2 gt squared. What can we fill in immediately? What do we know? What do we know? We don't know distance. We're trying to solve for distance, right? So we know g, right? So what do we put in for there? 10. Sure, makes the math much easier. What's the time? 1.5 squared. Due to our order of operations, what is the next thing that we do? Someone said it. Exponent. Remember, please excuse my dear Aunt Sally. Parentheses, there's no numbers within parentheses in here. Excuse is e, the exponent. So we have to do this first. So 1.5 squared comes out to be 2.25. Does that sound right? 2.25 times, what's 1/2 of 10? 5. So 5 times 2.25 comes out to be 11.12. Now let's see. I'm horrible with math in my head. That's why I do it beforehand, so I can do this. .25 meters. Okay? That means the apple fell from 11.25 meters. Now, this is an easier way to do it. If I give you time, it's easy because people can square a number. If I don't give you the time, but I give you the distance and have you figure out how long it was falling for, it's a little bit more complicated. So let me show you how that works. So let's say I say an apple falls from a tree that is, 11.25 meters tall. How long will the apple fall? Well, if we know the distance is 11.25, we know that gravity is 10, and we have to solve for t. I think some people kind of now have a minor heart attack because they have to do some algebra. The algebra, guys, is not difficult. So this simplifies to 11.25 equals 5t squared. What is my next step? Not subtract 5. That is also a common mistake. Not yet. Divide it. We have to divide out the 5. Remember, we do the opposite. This is multiplication here, so we must divide out the 5. 11.25 divided by 5. Who can tell me what that's going to be? 2.25. So we are left with t squared equals 2.25. Now how do we get rid of a square sign? Square root. Do the opposite. So if we take the square root of this side, we must take the square root of that side. Square root of a square just leaves the t is equal to 1.5. All right? So that is the general steps that you have to follow given both of these scenarios. I can give you the time and ask you to get the distance, or I can give you the distance and ask you to solve for time. It's all just understanding the algebra. If there's a square sign, to get rid of the square sign, you do the opposite, which is a square root to both sides. Okay? And that is it. That's just the very basics of understanding acceleration due to gravity and objects in free fall. How how many of you are going to need some more time for your calculations in your lab? A couple people? That's cool. You will have some time. I'm going to stop my recording. I will have this on my website after school, so if you need to go back and revisit this, you totally can.